Good morning, everyone. Woo, yeah. So I'm back here for the day 3 keynote, and we have a lot of really exciting things to talk about. Because one of the things that we do is we really like to try and spend some of the time we spend here at NGConf looking forward towards the future. And that's sometimes a little scary for us. But so before I get started, my name is Stephen Fluin. I lead developer relations for the Angular team. And as always, my 2 missions in life are 1, to help developers and businesses be successful with Angular, and 2nd, to understand what it's like in the real world, what the real challenges developers face, so we can reflect those needs onto the team. So we're going to start off this morning talking a little bit about ideation, because we do a lot of thinking about the problems and the opportunities across the Angular ecosystem. And we want to share a little bit about how we think about that process. And then I want to give everyone a status update on some of the things that we've talked about before and some of the things that are going on in our community. But I personally have a problem, right? So I gave that little intro about what I do and what my mission is. And one of those is help developers be successful with Angular. But this can actually be a little bit challenging because everything we do is in the open. Every PR, every commit is public, right? We do all of our work on GitHub first, and then we sync it back wherever it needs to go. And what this means is that sometimes when we make commits, we send PRs, they show up on social media or the front page of Reddit, in the Angular subreddits. And oftentimes when we see these things, they don't have the context of why we're doing them and the thoughts behind them. And that's something that we're here to talk about today. Because not every line of code that our team writes is going to affect you as developers or any of our users. Some of the things that we build are just proofs of concept. Some of the time, we actually, in order to innovate and to continue to evolve the platform, have to brainstorm. We have to come up with ideas, try them out, and see how well they work. And oftentimes, some of the things that we're doing are just behind the scenes. We're changing private APIs. There was an example where there was a commit where we renamed ng4 of, but it wasn't the one that everyone uses. It was a private API. There was an underlying implementation detail. And people didn't really understand that when we just put that commit out there. And so I want to present a little bit of a framework for thinking about how ideas and concepts and capabilities evolve when we talk about Angular. Now, this is not a super formal structure. This is something that we didn't set out to do intentionally, but it's something that I think has evolved naturally, and that we've seen that all of the capabilities that Angular has have followed this. So it goes from idea to theory, then something becomes possible, then we try and make it easy, and eventually we might try and make it automatic. So I want to go into each of these. So let's start off talking a little bit about ideas. On the Angular team, we have a lot of ideas. This shouldn't be a surprise. We are always coming up with, hey, what if we change this? What if we change this? What if we change this? And a lot of those ideas are really, really important to understanding kind of where we're going and in terms of reacting to the community needs. But at the heart of an idea is an understanding of a problem. And at this stage, we typically have some level of knowledge of the various approaches that we could be taking. And sometimes that idea, we stay so excited about it, or someone is so passionate about it, that it might become a theory. So then we've elevated a little bit. Now we're considering one of those approaches. We're saying, what if we actually went and did X in the platform? We made this change, or we introduced this new capability. At that point, we're really doing things like design docs, proof of concepts. We're trying to figure out if the change or the capability has the desirable trade-offs that we want to offer to the community. And at this point, we're trying to say to ourselves, let's either prove it or disprove it to ourselves. It's a theory. Then, once we have the theory, we'll oftentimes, if the theory works out and we feel like the approach makes sense, we'll move into making it possible. This is where we start building out things like underlying primitives. And oftentimes, you'll see this manifest as separate tooling. I think Angular Elements is a really great example that was at this stage where we wanted to build the primitives that let people create and render custom elements from Angular components, but we didn't build the full set of tooling you'd need to build these on your own. We kind of left some of that to the community. If something's possible and we feel like developers are responding really well to it and it's adding a ton of value, then we move into trying to make it easy. This is where we really start going after things like documentation. We start writing blog posts. We start writing communications and say, hey, this is a feature or capability that you should try out, that you should start using. This is where we really hold ourselves to a higher quality bar. Oftentimes, you'll see things that are easy as opt-in or self-run commands. Right? If we think about the path that Ivy has taken, our hope is that in the next month or so, Ivy is going to be easy, where everyone can take advantage of it. You can try it. You can let us know the feedback. You can let us know where it breaks your applications as we continue our journey. And not every feature, not every capability gets past easy, but the ultimate goal, whenever possible, is to try and make the capabilities and features automatic. So this is where we start building out things like ng update schematics. So we automatically add these things into your application. A really great example of this that's landing in 8.0 is differential loading. Right? We had these capabilities before. You could do it external to the Angular CLI process. You could build some of your own custom tooling. But now, via schematics and via our tooling as it evolves, we're baking these things directly into the platform. Oftentimes, we want these things to be the only way of doing things. And this is actually one of the important concepts in Angular, is that in general, we want there to be one way of doing things. One of the top reasons that people say that they like Angular is our opinionated nature. And so this is really, really essential to us. And so if we're introducing a new way of doing things, we want to understand what's the vision for that. How do we find a way to make this maybe the only way of doing things so that everyone is writing the same code and it's all working the same? And at this point, the sort of capabilities are fully integrated into the platform. Whether it's CLI tooling, whether it's other features like service workers, we've thought through all of the kind of ramifications and impact across the entire platform. Now remember, not every idea is going to make it all the way. Some ideas die as ideas. Some get to theory, and we build a proof of concept, and we say that's not the right approach. Some things we get to easy, but it doesn't necessarily make sense to deploy automatically for every Angular developer out there. I also want to call it that it's not always as smooth or as clean as I tried to make it look in that slide. Right? Sometimes something might be hovering between possible and easy, and it's up to you to interpret how you want to think about that model. And lastly, I want to say that we don't do any of this alone. We are so fortunate that so many of the ideas, theories, principles, and capabilities that we build into Angular actually come from the community. Two examples that I really love to highlight are Ivy itself. This was actually a community idea. Other people had built some proof of concepts, and we worked with them to pull that in. That was the folks at Amadeus. Other examples are working with the folks over at Forbes on our server-side rendering story. This is so essential because ideas don't just come from us, right? They come from everyone, and we all want to collaborate, and that's why we've been so successful, is by working together with everyone. One of the labels that we use to identify some of the projects that are not yet fully stable is Angular Labs. So if you look at the first half of that list from theories and ideas, anytime we write code there, we're trying to put this Angular Labs logo on it. And Angular Labs really talks about a project that has an uncertain endpoint. Oftentimes, we'll start getting into a problem, and we'll say, hey, maybe we were focused on the wrong thing. Maybe we were focused too much on runtime performance, not enough on Bootstrap performance, or things like that. Oftentimes, the APIs will change, right? We make very, very strong commitments about our public API, and we want developers to be able to rely on us and continue to write the same code they've been writing and keep their applications as up to date as possible. But with Angular Labs, sometimes those APIs need to change as we get feedback from the community. And I would say with Angular Labs, failure is in many ways an option, right? We don't know that this is necessarily the right way of solving a problem, and we might want to say, hey, we found a different path to solve that user need. I want to look back a little bit on some of the projects that have gone through this, because we've introduced these, but we haven't always done a fantastic job of following up and saying what has kind of graduated from this process. So back in 2017, we had the Component Dev Kit, or CDK, graduated from Angular Labs. In 2018, we had Elements and Schematics. And then we're expecting with the 8.0 release that this Builders API that lets you tap into ng-build, ng-serve, will actually be part of the stable public API of Angular, and we'll be graduating from Labs. So definitely stay tuned to Alex's talk about that a little bit later. There's also a bunch of current projects that we consider Angular Labs projects. We're doing a ton of work on Bazel right now to make it a really good tool for scaling out your builds and getting better performance, better incrementality. There's also two other projects from the Material team that I want to highlight because I think not a lot of folks know about these. The first is called Material Experimental, and the second is called CDK Experimental. So these are packages that live in our GitHub repository, but they're also packages on NPM. And so if you want to, in addition to Angular Material, you wanted to install @Angular/Material Experimental, you can actually get a glimpse at some of the new components, some of the new features that we're working on in Material. So this is actually the first place that we land those things when we're uncertain about an API and we need developer feedback. We need people to try these things and prove them out with us. once you've imported it or added it into your project, then you can actually just import the specific component or capability from the CDK or from Material from that specific endpoint. So it works just like Material and CDK, but you can go in and you can, as I said, get a sneak peek. We actually have lists of these things on our GitHub, so I've created a couple short links here, so bit.ly mat experiments and bit.ly CDK experiments, if you want to go and take a look at some of the experiments that they're working on in Material and the CDK. I do want to say that each component can be at a different stage. So I laid out this idea to automatic framework. Not every component is at the same stage there. So we're talking a lot about ideas and theories and all the sorts of things that we're excited about. And this is something that we really want to lean into a little bit more. Because we want to do better. Oftentimes, we're a little bit afraid to share some of our ideas because we, as you saw, sometimes our commits end up on Reddit without the right sort of context. But we do want to do better. We want to echo the needs that we're hearing. We want to make sure that everyone in the audience knows when you share a feature idea, you share a pain with us, we are hearing these things and we want to make these things better. We're going to continue to evolve Angular. We also want to share the problems that we see because oftentimes we have unique insights into the capabilities and the awesomeness that can be around in Angular. And we really want to embrace openness. And so with your help, I want to lean into and share some more about these ideas and theories that we've been working on. But I also want to say we are committed to you. We've been making commitments for a long time now that we want to bring the world with us. Igor talked a couple days ago about this idea, this guiding star of Angular Evergreen, where no matter what changes we make to Angular, we're going to bring you with us, we're going to make it a smooth transition, and we're going to listen to the community and make sure that you're not having to relearn everything. Right? We want to bring everyone with us, and this is critical. And it's not just critical in terms of our promise around our product, but it's actually critical from us from an engineering standpoint, because as we've said before, there's over 1,000 projects at Google that use Angular. And it's actually our team's responsibility to make changes to them if we break them. Right? So every time we make a breaking change and we create pain for you, we're creating pain for ourselves. And this is a really nice balancing factor that makes sure that we evolve everything very carefully in the right way that gives you both the benefits of stability and the benefits of innovation, because the ecosystem is not static, right? We can build better apps today than we could build last year, and we're going to be able to build better apps next year than we can build today, and we really want to be a part of that. And at this point, we actually have a successful track record that we can look at. Brad talked about the KLM story of how every update has gotten easier and easier and easier for them. And this is something that we definitely care a lot about, is continuing the more than 2.5 years at this point that we've done where we've brought everyone with us. So what I want to do is I want to introduce Miško, and I want to give you a glance at some of the ideas and theories that we've been working on. Some of these might not land for years, some of these might not land at all, but again, we really want to embrace that idea of openness. So let's introduce Miško.
Thank you, Steven. Good morning, Salt Lake City. How are you guys doing? Hi, I'm Miško. I'm one of the tech leads on the Angular team. And today I want to talk to you about our ideas for the future. Now, you might not notice about me, but I love crazy ideas for the future, and the team always has to talk me down off the ledge. And so this might be one of those times that they haven't succeeded in talking me down off the ledge. The thing I want to talk about, oh yeah, that's me. The thing I want to talk about is what are we thinking? In the past, we have not really shared as much about the future, where we're thinking about taking the Angular, for the fear of that maybe people will a little bit freak out about what kind of crazy thoughts we have. But we wanted to, because we're open source, we wanted to say, hey, let's take the open source community with us and give them lots of warning that this might be a roller coaster, but allow them to see where we are going. And so one of the things that is top on our mind is how to build as fast as possible apps. In order for the web to be successful, this is one of the things that needs to be solved. And there's a lot of ways to measure a fastest possible app, but one thing in specific we were talking about is time to interactive. That is, I go and navigate to a website, and I want to start interacting with the website as soon as possible. And so how can we increase time to interactive, or rather, how can we decrease the time to interactive and make it as fast as possible? And it turns out that time to interactive really comes down to network time and parse time. In other words, the less code you have, the faster you will become. And this is especially important for the initial time because the browsers, when they first see your code, they still run in interpretive mode, which is the extra slow mode before the jitter can kick in and get all the information. And so at this mode, we're actually pretty slow, and so the amount of code you ship to the browser really is the determining factor of how fast your application will bootstrap. So how do we get less code into the browser? And you might actually know the answer to that question, and that is tree shaking, and we've been talking about it quite a bit. However, it turns out that there's a difference between the code you will need versus the code that you might need, right? There's a difference between you for sure know that in order to render the initial page, you have to execute this code, whereas there is a button where the user may not click. And because the user may not click this button, it's only a might need code. And it turns out that tree shakers aren't able to tell the difference between those two, and they will include both of the code for you. Now, we kind of already have a solution for this. We have lazy loading for routes. In other words, if you don't go and visit the about page of the particular website, or if you don't go to the settings page, we don't bundle that with the initial download, and we don't ship it for you. However, we need to do the same thing for the buttons as well. So if you don't click on a particular button, you don't need to actually download that particular code for you. Now, in order to know which buttons are clickable or not, you kind of have to execute the code already once somewhere, preferably on a server. And so a lot of this talk is going to be about the ideas of how we can pre-render the application on a server and then deliver it to the client in the fastest possible way. So one of the things, so buttons are one place where might need code is hiding, but there's other places where your might need code is hiding. And that is when the application first starts up, almost all applications, the first thing they do is they go and fetch the data for the application. And this is kind of strange because the server just did that for you, right? The server pre-rendered the web page for you so that the initial render was super fast. And now the application wakes up and replays all of the operations that the client just did. And so we need to provide more lazy loaded boundaries for these kinds of things. And we're going to be talking about the difference between replayable and resumable things. But the idea here is that Angular currently provides a lazy loaded boundary on routes, but we need to provide lazy loaded boundaries in much more places, not just routing. So that it is more fine-grained, and we have a better control about only shipping the code to the browser that the browser actually needs to execute. And so a good way to measure that is that when you open up your browser, there's a little coverage button you can get in the DevTools. And the coverage button actually tells you how much of the code your browser has actually executed on initial render. And so any code not executed is the code that's really the might code that you probably should be thinking about. How do I get rid of it? And so let's talk about the difference between what I call replayable applications, which is the applications we have today, versus where we want to get to into resumable applications. And this is kind of the way to think about it. Today, if you're on a server and you are running the application on a server, you kind of get the application bootstrapped, the application wakes up, fetches the data, it renders the UI, the server then serializes the UI into HTML, sends it to the client wakes up, gets the code, and it does the same exact thing on the client. It needs to figure out how do I get to the same state as the server was when the server left off. And so it replays all of the operations. And to do that, it bootstraps itself, it fetches the data again, it re-renders itself and replaces the DOM tree with the new render tree. Hopefully the two trees are identical so the user doesn't notice. And only then do you have an interactive application. And instead, what I would like to talk about is how can we have a resumable application where you can resume the application from the point of interaction. And cut out all of the intermediary step because those intermediary steps turns out is a huge amount of code that your browser doesn't need to execute. Or preferably if it didn't execute, you would have a much better time to interactive. The thing is that replayable is a simpler way to build apps. It is what we are familiar with, it's what we do all the time, and it is very, very simple to do, and we are very comfortable with doing it. Resumable, though, is smaller, even if it requires more work and it's a little bit harder to do. But the payoffs are worth it. Now, does it mean that this is something we should do for all the apps? No, it doesn't. It really depends on the situation you happen to be in and what you're building. If you're building an enterprise app that is going to be opened once in the morning and it's going to stay open throughout the day, that is very different use case than a homepage app for a site that's selling shoes or something. Now, in order to be able to resumable, one of the key things that Angular has to do is it has to be aware of the state of the application. And so not only do we have to serialize the HTML and send it to the client during server-side pre-rendering, we also have to be able to serialize the state of the application and send it to the client as well. And so the last bit is, currently, when we do server-side rendering, we destroy the old DOM and we recreate a new DOM and put it in its place. And as I said, hopefully the new DOM is the same as the old one, and so the user doesn't notice. Unfortunately, that doesn't really work in a partially rehydratable applications. What I mean by partially is that we would like to get to the state that if there is many components on the application, we should only rehydrate the component that you're actually interacting with, right? So if you don't interact with a particular component, there is no need to load its behavior to the browser. And for that, we really need to be able to rehydrate the state of the DOM, because the user might interact, might focus on a particular input, might start typing into the input, and then when the application bootstraps, or rather when the components lazily bootstraps, it cannot replace the typing that the user has done, because doing so would destroy the focus and what the user has typed into it. And oftentimes it actually creates flicker as well. Now, I know we've been talking a lot about Ivy, and so I really want to point out that Ivy is kind of the enabler of the whole thing. It enables us to build these kinds of applications. So Ivy continues and will be our type priority, and these things that I'm talking about is really just ideas about the future of how we are thinking about the platform, not something that we're currently working on. Without Ivy, we won't be able to do this, and so I'm super excited about Ivy, mainly because not just the things that the Ivy will do for us today, but the kind of things Ivy will enable us to do in the future. And so I'm about to show you some code, and I want to give you a big disclaimer. The team made me put this here. That is, what you're about to see is totally made up. It may never be delivered. It will probably look very different if it does get delivered. It is not our top priority because Ivy is, and a lot of it is hand-wavy. But I think it's important to talk about it because it's important to share how are we thinking about the problems that we have, and how are we thinking about making the ecosystem better, and how are we thinking about it in a way that brings everybody with us. But first, let me introduce you to Mr. Paperclip. No, it's not the same Paperclip you're familiar with. It's a different one. The reason I have a paperclip here is because whenever I talk about new syntax with people, syntax is kind of like the cuisine you happen to grow up with. You immediately have these either an allergic reaction to a different cuisine's food, or you absolutely love it. And syntax is the same kind of a thing. And so what's important about syntax is that syntax is something you can change later, but the key thing that people always miss about syntax is it's not the syntax, it's the semantics. It's the meaning behind the syntax that you should be discussing, not the syntax itself. And so to distract everybody from the syntax, I'm going to put paperclips everywhere to let you know this is not the syntax. This is just a placeholder where something of that kind of like information will have to be placed. So look for the paperclip. So let's build a to-do app. And a to-do app is a simple app that you've all built many times before, and so that's why I want to start with it. And I would like you to imagine what would it take to make it fast. And I would like you to take you through that journey. So let's start with something, let's say we have a to-do app and we have a to-do app component. And the to-do app component has a very simple state, which is just it has items, which is a list of items. How do we get the items? Well, the async method on the bottom, the reload method, can go and fetch it. But notice the fetching requires item service. How do we get item service? Well, we have a constructor and it be injected into the item service in here. And now you can kind of start to see what I mean when I say replayable. In order for us to bootstrap the to-do app component, the to-do app component will immediately call the constructor and will immediately start fetching the data, and it will start replaying itself. And a thing that I really want to point out is that the amount of code that is hiding behind the item service is huge. It's probably most of the application. Because behind item service is probably common, Angular common HTTP, and probably some caching mechanism, and who knows what else over time gets placed into the item service in order to provide the capabilities that you need for your applications. So if you want to talk about how do we make the application resumable, what we need to really talk about is how do we make the item service not be as part of the constructor, and how do we make sure that the constructor or ng on init don't do complicated set of work. So this is this is what we do today. For the template, you can see on the top, we just have a ng4. We'll iterate over the individual items, and we bring a second component in, which is the item component. And we have a button on the bottom that's a little bit contrived, but I wanted to just demonstrate how the click listener works. So we have a button to reload the state of your to-do application. So pretty straightforward stuff. You should be all familiar with this as we do this today. For the item component, we have a similar thing where we have an input box, which is just a checkbox, which is data bound to whether or not the item is completed. And when you click on the checkbox, it will call the toggle method, which will change the state, right? This is the side effect of the application. Now, in this case, the changing of the state is absolutely trivial, but you can imagine when your applications, the changing the state is something more complicated, but the same set of rules will apply. And so this is our item component over here. And if we do server-side pre-rendering, this is kind of what it would look like. The server would execute the application, build a DOM on a server. We would then serialize the DOM on the server, ship it to the browser, and you would get something along these lines. So this is not something you would write, right? This is something that the server would generate by executing all the components together. And when we would get to the client, the first thing client has to do is to bootstrap the application all over again. And the reason we have to bootstrap everything again is because we don't know where the listeners are, right? As you look at this particular HTML, there is no idea where the listeners are, and so the framework really has no choice but to bootstrap the whole application end to end, every single component, in order to figure out where all the listeners are and where do we have to place them. And so this is the problem we have, right? We are replayable again. We have to register listeners. We're going to have to rebuild the DOM. The fetching of the service will have to bring in the dependency injection system. The dependency injection system will then bring in services that will fetch data from the server. And before you know it, we're essentially shipping the whole app into the client. And so our goal now is to make the above lazy. How could we do that? So make the application resumable is the goal. And the way we do this are two parts, which is that one is we've tried to figure out how to make all of the unnecessary code lazy loadable. And two, we try to figure out how do we resume the state of the application rather than replay the state of the application from the client. And so, again, we're back into what the server would generate for us. So we might look something like this again. And the first piece of information that we need is where are all the click listeners? Where are all the listeners so that I can interact with the application? And so one of the things that the server could do for us is to actually place markers, basically annotate the HTML coming from the server with additional information telling us these is where the clicks are. Now, why is this important? This is important because now we don't have to eagerly bootstrap the application, and instead we can do it lazily. Now we can register a single click listener at the bottom of the DOM tree and say, when a click happens, figure out where the click comes from and look for these markers inside of the DOM tree. And using these markers, determine which component needs to be bootstrapped. And so we need to have a second piece of information, which is where exactly the components are, and if they get triggered, what exactly has to get bootstrapped. So in this particular case, what we can say is that, hey, when you click, for example, on the reload button at the very bottom, the reload button will trigger the framework to say, okay, I need to go and find the closest component. In this case, we go up to to-do app, we find the component, and we bootstrap that, we lazy load that particular, we do dynamic import on that particular URI and bring the component in, and then we can bootstrap the component and execute whatever the reload button will do. And notice what we don't have to do at this point is actually get the items to be executed or brought in just yet, because the reload might actually have some side effect that actually doesn't require the item to be executed. So we can delay that. However, if we look at the to-do app component, we're back into square one, which is that we are going to reload. As soon as the to-do app component is going to be bootstrapped, we're going to reload the state from the server. And so this is something we need to work on. We need to fix this particular problem. And one way to fix it, so the problem is that the component rendering loads the side effective behavior from the server, and as a result, we are again in the square one where we bring the data system, we're bringing all the parts. This is kind of the core of the problem that we need to solve is how do we not do this? And so one example would be that if Angular could understand the state of the application when it was serialized at the server. And one way to do that would be to have, for example, again, this is made up, notice the paperclip, would be to have a state marker to say, hey, when you serialize the application on a server, not only do you serialize the HTML and send it to the client, but also serialize some of the state of the individual components. And by doing this, the semantics of this thing could be something like this. That first, we will assure that whatever you put in items is something that can be JSON serializable. So the state annotation will have additional information for you. The other thing we can do is we can say, hey, if the application gets bootstrapped and there already is a state that's available for you because the server has provided for us, then don't bother executing the function that's associated with the state. In other words, only execute the function if the server did not provide state for you. And in this way, we get to not execute some amount of code that is unnecessary on the client, and we simply assume that when the application gets bootstrapped, the state is available for us. Now, that helps with executing less code, but it doesn't actually help the tree shaker from removing the code. So we need to do more work. One thing we could do is we could, instead of calling the function directly, we could put dynamic imports at those locations. And notice what we have done. Now we're told the state that if the server did not provide state, the way you get it is you go do a dynamic import at this location, and you can see what the function would look like at the bottom. Now, by moving the function at the bottom, not only did we have to move the function, we also had to move the services. And by moving the services, we now have a component whose constructor doesn't require us to bring a lot of other dependencies in. And instead, we can lazy load the dependencies only if somebody decides to either click on the reload button or if the application comes and the server did not serialize the state and we actually have to fetch the state. And so this is the basic idea or basic trick that we could do in order to put more lazy loadable boundaries into the system. But for that, as you can see, the framework has to be helping by providing us a way of serializing the state. Because without serializing the state, the application will always have to be in the realm of replayable applications. Now we can do another trick, and that is, notice that there is this reload method that actually doesn't really do anything other than forwards onto a method call. And so perhaps we can even make this even simpler and allow us to put the import statements directly into the HTML. And in this way, the to-do app component becomes really, really trivial. And by becoming trivial, it becomes resumable. And it becomes, we have now a world where it's easy to bootstrap individual components on as-needed basis in any order necessary in the application. We no longer have to bootstrap the whole tree of applications, whole tree of components using the normal bootstrapping process. And we can become truly lazy. And we can get to the point where we can download the code only necessary for running that particular operation of the application and nothing more. The other thing I want you to point out is that the dependency injection system, instead of being eager and being in the constructor of the component, has moved now into a function call and will only get invoked if somebody performs this particular operation. And so we can gain other benefits by moving the DI system over to lazy loaded parts. So the thing I wanted to point out is that you can't really do this unless you have state. State is the thing that makes the thing possible, right? And so one of the things that we're thinking about is how does state of the application, is state something that Angular should get in the business of? Should we get in the business of basically keeping track of it? And if you want to do resumable applications, I think the answer is yes. And we need it for two reasons. One, because we need it for partial bootstrap, right? We want to have the idea that individual components can get bootstrapped in any order necessary in order to get the application going, and the components that you don't need right now, we shouldn't be bootstrapped just yet. And we need it because we need to resume the component. Because without the ability to resume the component where it left off at the server, we are back in the world of bootstrapping the whole system and executing all the components. And so we want to place lazy loaded boundaries on interactions, on injected services, and on code needed for re-rendering. And by placing all these lazy loaded boundaries in a system, it doesn't mean that you should do it everywhere. What it means is that if the framework doesn't do this, if the framework doesn't allow you to do this, then you will have a hard time doing it on your own. And by framework introducing these lazy loading boundaries, it doesn't mean that you have to place them everywhere. You have to still decide whether it makes sense or not. But you have the capability that you didn't have before. And so I feel like this is something, an important change that would allow you to build faster applications and really have systems which are fully lazy loadable. So how do we send the state from the server to the client? One thing, because the state, as I said, has annotated inside of your components, we know which ones to collect, and we would also be able to, we also have a constraint that says the state would have to be JSON serializable, and so as a result, it would be really easy to collect all of the state. We know the structure of the application, and then place it at the bottom of the rendered HTML that's being shipped to the client. And so in this way, the state can get parsed on an as-needed basis when the components are bringing in. And I cannot overstress this, that app is a collection of components, and the thing we are looking for is how to bootstrap each component individually so that we can get as little code in as necessary. This is in a stark contrast from how we bootstrap applications today, where we bootstrap the whole thing all at once. Here, we really want to go down to individual component level. However, this creates a problem. And the problem it creates is if you have an item inside of our to-do list, and we have a toggle over here, notice that the toggle is changing what's essentially a global state. The toggle, when it calls and it changes the completed to not completed for your particular to-do item, it doesn't know who else is listening for this particular property. We don't know who else is, who could else potentially have a reference to this object, and as a result, because you have a reference to this object, your change detection has to run. And the way we solve this today is we have Zone.js that detects these kinds of changes, and then Zone.js updates the application globally to update for this to occur. The problem is that if you individually load components into your application, you don't know what other components have to be loaded when you change a state that potentially other components could refer to. And so we have to fix this particular problem. Because if we don't fix it, you will very quickly get in a situation that any mutation will require you to load all of the components that we have worked hard to make sure that they're all lazy loadable. And so the way to do this is first we can mark the item as being a state as well. But we can also pull out the mutation, as you can see, into a separate function. And the key thing over here is that not only is state JSON serializable, but we'll also make sure that the state is not mutable. And by making it not mutable, we're basically allowing the code here to create a new state that it's allowed to write back into it and change it, and it knows that it hasn't modified some global variable somewhere that some other component might be referring to, which might require the other component to be updated. Now, if you do that, what is then also required is that the state also fires an event and says, by the way, I have changed. Does anybody care about the fact that I have changed? And so in this case, when we go back to the to-do app component, and if you look at the first line above that says ng4, in there we say, OK, if one of these items have changed, please let me know. And if you think about it, this is exactly how input boxes work today in HTML. If you have an input box, a text node inside of your DOM tree, the text node doesn't mutate some global state. Instead, the text node replaces the value with the new value every time you type into it. And whenever the value has changed, it fires an event that you have to listen to so that the application can do something useful with this information. We're basically bringing the same exact thing over here. We're saying, look, what the to-do item is a more complicated check input box that has a more complicated model than just a string, but fundamentally it's the same thing. And whenever the model mutates, we need to know about it. And so the state annotation could also automatically fire a change event to let us know that, oh, by the way, I have changed. Do you want to do something about it? And so at this level, we can also grab it and then do the same exact thing for an array by looking for the old component in the old item in the array and replacing it with the new item in the array and then updating the state. And then there could be a component above us who will also get notified that we have changed our state. And if the component cares, it would automatically be bootstrapped and lazy loaded, etc. Now, one thing that I'm what I'm also thinking about is if you notice how the item change and the item in the square bracket and the item event in the parentheses, they look very, very close to be a banana in the box thing. And so it is probably possible through some heuristics to even simplify that so that one does not even have to write this line and it will just automatically be updated for it. So again, those are just some ideas we're thinking about it. And that's the reminder again. And we want you to be with us on the journey. And we want you to understand that this is not necessarily something that will happen anytime soon, but it is something that we are thinking about because we want you to be as excited about the future about Angular as we are. And unless we tell you about the cool new things we're thinking about, it's kind of hard for you to see where we're trying to take the project. And we also want to be more open about what we're thinking about, where we're going, and have a process by which we can engage the community more in these ideas. But keep in mind that just these are idea phases, doesn't mean all of it will happen soon, etc. All of the standard caveats. And finally, I want to really remind you is that some of these things might be, why did you move in my cheese? I'm already familiar with it. But keep in mind that we have a huge corpus of applications at Google, and whenever we do any changes, we have to also upgrade those applications. So we are extremely incentivized to do things that bring the community with us. And so we have invested a lot of time and effort into all kinds of tools that allow us to automatically upgrade the applications and so on. And so whatever things we are looking for in the future will be things where we can bring the community with us. Thank you.